Let's try this problem. So I want to find the value of x. So I have a triangle here, and I know this side is 28, this segment's 12, this is 3, and this is x, and I want to know the value of this. So immediately, because I see a triangle, and I see that I've got a side here and then a segment here that is drawn in that's parallel to this side, I'm thinking side splitter theorem, okay? And so I just know that I just need to set up those ratios and set them equal to each other. So the only thing that I notice, though, is that I don't have this piece, okay? And I'm not exactly sure what to do. So maybe I'll just call it y and I'll see what happens, you know? So, okay, so 12 is to y as 3 is to x. Uh-oh. I have two variables, and I'm not going to be able to solve for x if I also have a y. So I'm wondering if there's a way I can write y in terms of something. Oh, look at this. If I know this whole side is 28 and part of the side is 12, then that means y, the remaining side, well, that's just going to be 28, the whole side, minus this piece of the side, minus 12. And 28 minus 12 is 16. So, you know, instead of calling it y, I'm going to call it 16 because that's what it is. Okay, so I'll erase that right there. And I will replace it with 16. Perfect. Now I have what I need to set up my ratios. So I'm going to erase this just so that we have room here. Okay. So what I'm going to say is that 12 is to 16. Okay. 12 is to 16 as 3 is to x. Okay. So then I'm just going to take the cross products here. Again, always draw the butterfly. So 12 times x is 12x. 16 times 3 is going to be 48. And then I'm just going to divide both sides by 12. Divide both sides by 12. So I end up with x equals 4. Perfect. Just a little note on that division. I mean, some of you might be really good with your 12's tables, multiplication and division, etc. If you're not, that's totally okay. And sometimes a teacher may not allow a calculator for a question like this. So think about it this way. If you have 12x equals 48, for me personally, I'm really good at halving things and doubling things. So if I just divide this by 2 and this by 2, I can totally do that, okay? Well, 12 divided by 2 is 6. I'm really good at that. And then 48 divided by 2 is 24. Now, at this point, you might know, well, 24 divided by 6 is 4. But even if you don't, you can halve it again. So divided by 2, you end up with 3x equals 12. And then most people usually know at this point, oh, well, 12 is divisible by 3, divide by 3, divide by 3, x equals 4. Okay, so I just think that's another thing to think about. Like you're going to see in videos, I'm going to occasionally kind of come to the side and show you some sort of, you know, basic arithmetic thing that I use that helps me. Because people sometimes wonder how I do things in my head, and I don't have anything memorized. What I'm doing is multiple steps in my head. At once, like divided by 2, divided by 2, divided by 2, divided by 2 before I give an answer, even though it might look like I knew that off the top of my head, I may have actually done all these steps at once. Okay, so now that you see that, let's just quickly talk about how we can check our answer because checking your answer is so important, okay? So, let's see. All right, so we're saying that x is 4. So now what we're going to do is make sure these ratios are indeed true. So is it true that 12 over 16 equals 3 over 4? Okay, so 3 over 4 is as reduced as possible. But here, the greatest common divisor is going to be what goes into both. So, well, first of all, if you can't come up with the greatest common divisor, you can do what I did, okay? The concept of dividing everything by 2. So I know they're both divisible by 2, so let's start there. 12 divided by 2 is 6, and 16 divided by 2 is 8. And we want to know, does that equal 3/4? And again, both 6 and 8 are divisible by 2. So 6 divided by 2 is 3, 8 divided by 2 is 4, and 3/4 equals 3/4. So we are all set. We are right. We solved for x. So there you go.